Hello there, folks. This quick video today is going to talk about an Orbinox valve application, or a knife valve, if you will. And this type of valve is such that there's a knife blade that goes in straight across, and I think they call it a knife valve. In this case, we've got an air piston here, and we can feed air to the back of the piston, which will close the valve, and you can feed air to the start of the piston, and that'll open the valve. And in this video, if you watch it, there's a bolt here that's connected to the other side of the valve, and there's a couple limit switches. So as this thing goes open and close, you'll watch. So let's play the video real quick. So as you see there, it went to the close position in this application. So I'll just play it one time. Watch the valve. These are limit switches. And of course, it's a little roller. You could use proximity switches as well. But there is the valve that we're talking about in this example. And so what we've done here is we've created a couple of databases here to work with this as an example. Let me go back to the picture real quick. So on the picture here, I want you to notice there's two limit switches. There's one here and there's one here. So if it's in this position, then the valve is open because you can see the knife valve is back. If it's over in this position, it's all the way inserted into the pipe, and therefore it's in the closed position. So a couple rules to the game here is that the limit switches, first off, both of them could never be in the on position at the same time. That is invalid because there's a bolt here, unless some idiot is grabbing the rollers, which wouldn't surprise me. But anyway, in normal operation, it cannot have both valves cannot be on at the same time. That's one other thing. Also, when you watch this, when it's in the movement right now, look at, I'll stop right here. This valve is currently open, and this one is open because they're not in the closed position. So as it goes across here, now it closes this one. So obviously that means the valve is in the closed position here in this application. And this one's pulled back here. That means this guy's closed. It's in the open position. So there's a couple of rules here. Also in the same application, another thing that we had to follow is that after the valve got to the open or closed position, we needed to turn the air off on the piston so that we're not blowing air in here, even though it's already in that position. So we also needed to turn off the open or close command to the valve here. So in this case, I've got a couple of applications. I've got a database written here that is the PLC side of this that does the control. And then I also went a little further and created another database that actually mimics the valve status. So let's go ahead and play with this, and I'll show you what I'm talking about here. So on this side of the screen, this is the valve here. This is going to mimic the valve, just like in the video I just showed you. And then this left or the right side here is going to be the control. So if you look right now, according to the drawing, this here, the valve is currently in the open position because this sensor is currently in the on position. So if I send a command here to close it, you see there, now it closes and you can see the valve is moving across. Here's another reed switch on this side, and you can see when it gets to there, it goes to the on position, therefore it's in the closed position. And you can also see that the reed switch here shows that. Here's the part of the logic that was the challenge here. In our code, we were continually sending it in this case, closed position, and so it would continually hit it. So we actually changed the code a little bit so that once we got to that position, it's a known state. So if I was to say send it to the close again, you can see that this automatically goes off because it says, hey, I'm already in the position, so I'm not going to call again. But if I send it a command to open right here, now you'll see this reed switch went from that position to the red. It's going to move over to here, and now this triggers, and you can see in that case, the command went off. Also, I might point out to you a couple of things you'll see in this example. I can adjust the valve movement time, and if you watch that video, what do we have there? I don't really know. Let's watch this one time. 1, 2, 3, 4, 5. It's roughly 5 or 6 seconds for that thing to go across there in that example. So in the database here, I can adjust the movement time in here. Also, watch this graphic. This is what the customer is actually using on his system. So right now the valve is in the open position. You can see the valve here is green. If I send it the command for close, you'll see here that it goes gray because both sensors are currently off. and then not till it gets to where the other one goes red or goes to on that it goes to a red state. So you see that you have a valve in transition when it's gray. So when it's in transition, you'll get the gray color indicating it's moving, and then depending on which way it's going, it'll go either to red or green, depending on the state here. The other part of this that we did a little extra logic on is if I make the valve transition time, let's say right here you see it says 7 seconds. If I take longer than that, I get an error state. So let's say that we're expecting the valve to open or close in, say, 5 seconds. So here I am currently in the open position. So if I send a command here, I want you to watch that we're going to go to the close position. And after 5 seconds, we'll probably get an error here because it took longer than that to get to that location. So I can click here, accept it, and I clear it. Let's go ahead and make it go to the close. We're in the close position. Let's go to the open here, right here. So you'll see there's no alarms right now, but after 5 seconds, because I have the transition, you see there, it took too long, so that's why I have an error. But anyway, they can adjust this to a greater time. The important thing here is that this time is nice because after a certain amount of time goes by, you certainly want to know that, hey, I didn't go to the open or close position in the allocated amount of time. There's something going wrong. Why is the valve taking longer? Did it even move? We need to maybe send a person out to look that over. Anyway, this is a cool example of the valve Orbinox control, and there's a lot of really neat coding going on here based on the different conditions on this application. So if you want a copy of these databases, both the one that does the valve mimicking and of course the one that does control, don't be afraid to let me know, team, and I'll send these to you and share them to you. Hey, thanks a lot. Have a great day. We'll talk to you all later, folks. See ya.